Hi everyone. So good to be with you today. This is Mo from Morta, and I'm really excited to be speaking to you today about database-driven information management. And I'll be focusing on how databases effectively can be leveraged in order to make the tasks related to producing information management resources easier. So to give you a bit of background on myself, I spent a few years working within the construction sector. While working within the sector, I noticed that there were a lot of spreadsheets and documents that resulted in manual processes. And a few years ago, decided to make the jump and founded Morta with the goal of helping organizations move out of spreadsheets and documents and into databases. So I'll be talking you through this presentation based on our experience in the market and what we're seeing, and thanks for taking the time to join. So as we all know, the industry is faced with many challenges ranging from climate change to safety and fires and like the tragedy that happened in Grenfell, for example, and even the traditional schedule and budget overruns that are coming at a time when there are also wider macroeconomic issues. And for any one of these challenges, project teams have to answer questions. And in answering these questions, they need to answer things like what is the planned carbon footprint or what is the actual carbon footprint of an asset? Need to be able to understand and determine whether a building is safe and it's habitable. And then there should be program related questions like how long will it take to build and how much will it cost to build. And what we find is that in many of the projects, we rely on information in order to answer these questions, ranging from the design information that exists to project management information or information about the material that's being used, or the documents that exist and the information about the facilities and so on and so forth. So if we take embodied carbon as an example, we need to understand what is it that's going to be built. We need to understand some of the project management and the material management related activity, and we need to find some other information. The same goes if for fire safety related concerns. Again, we need to be able to assess the design information, and we need to be able to access information in a document management system. And the same goes on for various other criteria and questions that have to be answered within the context of a project. The challenge, however, is that the systems that we have today are far off from where we need them to be. We have processes that involve many different project participants, and they are involved in many different processes with information scattered across tens of different systems, hundreds of different Word and Excel files that are resulting in thousands of hours on manual processes that get spent on finding information or uh, re-entering information that's needed. And we think this largely stems from poor information quality in the industry, and that's hampering our industry and the productivity within the industry back. So when we think of information quality, there are six key dimensions effectively. The first is the completeness of information. So do I have the information that I need? And is all of the information that I need there? And can I use that? Uniqueness is the second criteria. And there we're really looking at, is this, so for example, if I have an email, that email should be unique. Consistency, so that's whether we're reusing the same reference values. So when we think about things like originator codes and zone codes and so on and so forth, that becomes very important. The validity of information. So is this information valid? Is it right? Does it meet the requirements that I set? If I wanted it to be a number, is it a number or not? Accuracy is it actually true? Is it accurate? Does it represent what we're trying to say? And timeliness is it available when I need it? And what we find is, as a result of having many different disconnected systems, as a result of having a lot of manual re-entry of data, the information quality is suffers in the industry, and as a result of that, we require many manual processes and to stitch things together to understand where a project is at. And that's often resulting in risks. So we think one of the key things that's needed is to improve information quality and to move to databases and to connect information together. And in doing so, we can increase productivity. And I'll be going into how we can start improving information quality using databases in a second. But one of the benefits we see from connecting information is the fact that processes can be streamlined so that their cycle time can be decreased. And depending on the process, it can be significantly decreased up to 80%. There are many different costs that are associated with the risks effectively or not being able to identify data and patterns and opportunities and insights from the data. So we think, and we're seeing this cost can be reduced as a result. We can start understanding the impact of decisions, but not just from a single, I think a lot of people talk about the single source of the truth. But importantly, using databases, we can start getting a single view of the truth. So that allows us to have data in different systems, but ultimately start connecting this data together to get a single view of where the project or a process is at. And then as a result of this can reduce project risk and ensure that the delivery is on time and on budget by reducing a lot of these risks and gaining this visibility over where processes are at and deriving the insights that are needed. One of the key components, of course, to this, there are many components ultimately to getting there, ranging from a process to upskilling people and so on and so forth. But ultimately, we think databases are key to robust information management. And to just step back, a database is ultimately an organized set of data that can be stored by a computer, that can be accessed and looked at in many different ways. And we see many forms of databases in our day-to-day lives. We use many forms of databases, ranging from our accounting systems. The Revit model is an example to a degree of a database. But effectively here, we have a few key properties for any database. First, there is storage. So I can store images, or I can store files, or I can store data as I need. The second is accessibility. So accessibility means that I can start splitting this data into different views that I can see in different contexts. Searchability allows us to search based on parameters that are controlled. Data integrity is key and is one of the key advantages of using databases, because we can clearly define the data types, which allows us to define what's acceptable and what's not. And finally, databases are designed so that different people can work together on top of them. So they facilitate in collaboration and in the sharing of information. Now, when we think of databases, traditionally, there are the backend databases that many applications are built on top of, and that some will store central data in, like a Microsoft SQL or a Postgres, and in some cases, even things like a Mongo. But what we're seeing is they tend to be technical, they have a very specific audience, they're not easily accessible by everyone within the team. So they're there as a data aggregator, but they sit in the background and they're not easy to access. Then more like one that we're probably all more familiar with are the traditional solutions that exist. So if you think of any of the ERP solutions, if you think about things like Construction Cloud, or even any of the asset management systems, they are built on databases and they do have structured data sets. But the problem that they often have is they are traditionally really rigid. So they're very difficult to customize, and they tend to be disconnected from each other, which then results in many gaps existing. And then finally, one of the emerging categories now to replace spreadsheets and documents are some of the no-code solutions that exist across industries, like the Airtables and the Notions of the world. As a company, what we're doing is we're building a custom information hub that is dedicated to the industry. So it has the properties and the accessibility of databases, has the templates that would come from the traditional software applications, and has the flexibility of the emerging no-code solutions. But importantly, it's there as a system to connect to the other systems that exist and to fill the gaps where a spreadsheet and a document exists. So to do that, we offer a low-code platform that empowers professionals to build custom solutions that are fit for their needs. And there are three key value propositions in that. So the first is allowing organizations to digitalize their processes and move away from disconnected spreadsheets and Word files and into a database that has the rigor and the connectivity of the data. The second value proposition is related to connecting the data, because now once I have this information in databases, I can start connecting it to other data sets that exist externally outside of the system in order to ultimately automate processes. And examples of automation could include, for instance, deliverables tracking and tracking whether a deliverable that has been planned has actually been submitted in a common data environment, like an A-Site or a Viewpoint or a BIM 360. So ultimately, what this looks like is the platform has a lot of the features that you would expect from something where you can view documents and information. So you have a sidebar, and there's a home page that you can customize to meet your needs. One of the things here that you can see is there's a Power BI dashboard that's embedded. And the key thing is all of the data that's within the application can be exported into other systems and accessed via API for analysis. Digitally rich documents can be created to replace Word files. So we see a lot of procedures that exist in Word files that that should be made more accessible and that should be searchable, and that ultimately require contributions. So they'll typically have examples of forms within them. So for instance, in that case, where we're looking at the risk management procedure, this is an example of a risk form that someone can fill out in relation to the risks in a project. And once that form is submitted, we're checking certain data quality here because it's been defined. So you can see that there are icons that represent what data types have been required. So in this instance, it's a percentage, and the impact, it's a drop-down list, and the severity, it's a drop-down list, which allows us to improve the data of quality as we're collecting the data. One of the other key things is that ultimately this data can be accessed in tabular formats in much the same way that you would organize it in a spreadsheet, with a few key differences. So one of the key differences is that a lot of these columns at the top here can be controlled so that people can't actually make changes to the names of the columns. You can see that certain columns are grayed out, and that's because they've been locked, because the user shouldn't have the ability to edit these values. One of the other key benefits is that information can be aggregated in different ways. So I can start grouping information by project or by status or by impact or severity, for instance. One of the most powerful things about using a database approach is these tables can then be, and the data within these tables can then be reused using views that are relevant for different contexts. So for example, looking at that risk register table, we can filter some of the values. So for example, here you can see that I have a project manager, and I want the owner to be filtered on project manager, which means I can give my project manager a view or a subset of the data that I have that's directly relevant to them. And that means that I can start reusing a lot of data sets in different contexts without needing to manually re-enter that information every time. And that ensures consistency between my data sets. And when we think of consistency of data, we see that in many different ways in the approach. But that ranges from being able to use things like select lists where you're referencing data in a table from another table, but it also equally is a result of views, because we can start reusing the same data within different views, which ensures the consistency between the data sets. Critically, one of the advantages that we're also seeing as a result of this approach is ultimately APIs can be used to connect external data sets. So in our case, as a platform, we've made the decision that anything that you can see in the front end can be accessed via API, which means you can export data out of the system, but you can equally import data into the system, and you're completely in control of the data. And we think that's one of the key principles of a lot of the database applications that we're seeing. As a company, one of the things that we've also seen is that there are a lot of templates that have to be created in relation to information management resources. So we've worked on a few projects with the Center of Digital Britain and the Construction Innovation Hub to make the standards, digital implementations of the standards. So this, for example, covers 19650 Part 2. And then in some cases, we've also we built a tool for the generation of information requirements based on a question and answer based approach. So that effectively allows you to determine the assets that are relevant to you and the types that are related to you, and then a custom set of information requirements is generated off the back of that from a bigger database. Ultimately, one of the things that we always see are spreadsheets cross faces within projects, and they cross teams and disciplines and work streams. And in much the same way, the application that we've built, because it has the flexibility of a spreadsheet and document, extends across faces and really helps glue the remaining pieces within a technology stack. What we're seeing is there are some really popular use cases effectively for this approach. That ranges from pre-construction documentation, so a BIM execution plan being a wider set of different documents that have to be created pre-construction, operation and maintenance manuals and risk management, employers' requirements, so that includes information requirements resources, but it also includes technical requirements in many cases that are typically being drafted on Word documents. We've digitized them with a few clients. And then one of the most popular is information deliverables tracking. And that's effectively an extension of information delivery planning. And there, what we're doing is we're facilitating the planning of the different documents and the deliverables that are being collected from the task teams. And then we're linking into common data environments like BIM 360, A-Site, and Viewpoint, and so on and so forth, to automatically track whether the deliverables have actually been submitted or haven't been submitted. And we're seeing that saves a lot of time from the project teams that are typically doing this tracking manually. In many of these use cases, we're having to integrate with other solutions. And as I said, the fact that the system has an open API means that you can pull and push data out of the system. Some of the examples of applications of systems we're pulling data from or to are BIM 360, Primavera, Revit, Viewpoint, Power BI, and so on and so forth. So ultimately, interoperability is really key to everything that we do, and the system can be highly connected. I think one of the last things that I just like to note that I think is particularly relevant here, one of the opportunities that we're seeing from databases is ultimately a lot of the resources that we're all creating like OIRs and AIRs and exchange information requirements and information standards and the information delivery plans. They're typically seen as separate documents, but what we're seeing is there's a lot of data, effectively, or tables that's underlying a lot of these resources that's shared or that defines the different resources. So things like project codes and originator codes and high-level responsibility matrices and the functional breakdowns ultimately all link to an information delivery plan, for instance, and are really important for an information delivery plan. And even though it becomes like a table, these can then be reused as different views as MI master information delivery plans and task information delivery plans. One of my colleagues will be speaking specifically about that, so please feel free to attend her call if you're her presentation if you're interested in learning more about information delivery planning and how a database based approach is relevant there. So that's effectively an overview of how databases can be relevant to you. I look forward to answering any questions that you have and hope you found this useful. Thanks.